As promised, this is your Unit 6 Multiple Representations review. In this video, I will be going over intersecting lines, creating tables of values, creating equations, and of course creating graphs. I would highly recommend that you also go back and review the video I made on solving 1 and 2 step equations. All of these things will be on the upcoming test, so enjoy. So we'll begin with graphing intersecting lines, and we're going to use cubes, or a shortened version of cubes, to analyze this question. The problem: 2 TV stations offer deals for putting ads on. The cost for a 30-second ad is as follows. Global has a $20 initial charge plus a $1 per day charge. CBC has a $12 initial charge plus $2 per day. When would it be cheaper to use the first option? When would it be cheaper to use the second option? So with cubes, I got to circle the numbers. I'm just going to underline because with my pen here, it's not so easy to circle accurately. So we have 20, 1, 12, and 2. Okay, and when we do linear equations with word problems, it's good to know what these things represent. So we know that this initial charge is going to be our y-intercept. And we know that the $1 per day is going to be our slope. And same thing applies here, that our 12 is going to be our y-intercept and 2 is going to be our slope. Then with cubes, we're told we should underline the question. So we'll underline the question here. When would it be cheaper to use the first option? When would it be cheaper to use the second option? And then we should box any key words. Well, if you wanted to box here, you would box initial charge and per day. And then we would box those words because they let us know which one's the y-intercept and which one's the slope. Initial charge means it's the y-intercept. It's going to be the value of y when x equals 0. And we know that $1 per day is the slope because that's how much it's going to be going up by each time. Each day, I should say. Alright, so after we've done cubes, we're going to write an equation. So for global, the equation we would write would be C for cost equals X. Now it says $1 per day. We can write $1 per day as just X. It's this 1X is the same as writing X. We can just leave it as X. X, and then what's the y-intercept? Y-intercept is B, so X plus 20. And then for CBC, our equation is going to be cost equals, in this case, the slope is 2, so we write 2x, and the initial charge is 12, so we write plus 12. So now we have our equation. The next thing we could do now is we can create a table of values. To create our table of values, I'm going to need to remember that on the left side of the table of values is always our x variable, and on the right side is always our y variable. So I'm going to create one for global first, and my x variable is going to be the number of days. So I'm going to need to put a label of number of days in the x column of my table of values. And for my y variable, it is cost, so I'm going to put in cost for that. Now, I'm not going to do my number of days as going by 1. Because, well, most people are not going to be interested in running an advertisement for 1 to 5 days. So I'm going to go by 5 instead. And my x variable column is going to start with 0, as we've been doing. So 0. And what's the cost for 0 days of advertisements with global is the $20 that I have to pay as my initial charge. And then, as I said, I'm going to go by 5, so this is going to be 5. So remember, it's $1 per day, and so I'm going to get the answer of 25 because $1 a day for 5 days is $5 plus the initial charge gives me a total of 25. And then I'm going to do here 10 and 15 and 20, and this is going to go up by 5 each time because, or the y column is going to go up by 5 each time because it's $1 per day, and I'm going to be going up by 5 days. So the next one's going to be 30, 35, and 40. All right, so I have a table of values for global here. Now I can do the table of values for the CBC. And in the left-hand column, I'm going to put number of days. And again, I'm going to use the same interval for the x variables as I used for global. So I'm going to go up by 5. So I'll just write those in now. So for the y column of the table of values, I'm going to make that cost. And so now I can fill in the y values. For 0 days, the cost at CBC is going to be $12 because there's the $12 initial charge. So I would write in here 12. And then it's $2 per day. So for 5 days at $2 a day, that's $10 plus the $12 original fee. That's going to make it 22. And again, you see that it went up by 10. It's going to continue to go up by 10 because for each 5 days it's going to be 10 extra dollars. So my next one is going to be 32, 42, and 52. And we've thus finished writing our tables of values, and now we can go on to graphing these equations. So to graph the two equations, I'm going to have to create a title for my graph first. So I'm going to make the title Advertising with Global and CBC Number of Days versus Cost. I now need to label my Y and X axis. And I've labeled my y-axis cost and my x-axis number of days. I now need to put the numbers on my y and x-axis, and I'm going to use the interval of 5 to do so. So you can see I've entered in my values for along the x and y axis, and I've used an interval of 5. So I can begin plotting my points now for each of my equations. To do that, I'm going to want to look back at my table of values. So I'm going to do global first, and with global I can see my first coordinates are 0, 20, so, because I have the 0 here, that's my first x coordinate, and my first y coordinate is going to be 20. So I go up to the point 0, 20 on my graph, and I mark it. And then my next point is going to be 5 and 25. I can mark that as well. And my next one is going to be 10 and 25, or sorry, 10 and 30. So I got that marked. And then 15 and 35. And then 20 and 40. And I can see the general pattern here now, that it's going up by 5 each time. And I could write the rest of my points without needing to have a table of values for all of them. That one's a little too messy. Okay, so you can see that I have my points going all the way up. And then my next one is for CBC, and that equation is 2x plus 12. I'm going to use my table of values for that as well. So my first point is going to be 0 and 12. So I can put that on my graph here. And then my next one's going to be 5 and 22. And then 10 and 32. And then 15 and 42. And 20 and 52. Alright, and so my graph would continue to go up in the same pattern. And we know my next would be 62. So I'm just going to put it so you can see it being done. And then my last one that I'll put for now is going to be 72. So my graph was getting a little bit messy there with my stylus, so I decided to make the graph on Desmos so you could see it looking a little neater. Obviously after I had put all those points, you'd put lines through those points and they would look like this. And this here would be the price of CBC. And this one over here would be the price of global. So now I need to look back at the question. The question asked me when would it be cheaper to use the first option and when would it be cheaper to use the second option. So just to refresh your memory, global was the first option. So we'll underline it with red here. And CBC was the second option. So let's look at global first. And the answer to this question can be found in the graph by looking at when the values along the red line are lower than the values along the blue line. So when are global values, which is red, lower than the CBC values, which are blue. And so I can see that on the graph, all this part of the red line is when global is cheaper. I can also see that my point of intersection is right here. And that point of intersection represents the point at which the cost of getting advertisements from global and CBC are exactly the same. Now it's a little hard to tell on this graph, but this point represents 8 days, and it would go down, excuse my not so straight line, it would go down, and that represents 8 days. That line here before 10 is 7.5, and right after it would be 8. So I know after 8 days, global is cheaper. Now if I wasn't sure from looking at my graph, I could tell this by writing the equation and checking to see what the price is at 8 days and then at 9 days and comparing the two. So for global, C equals X plus 20. And if I check for 8 days, so I'm going to substitute 8 in for X. 8 plus 20 equals 28. That was for global. And then for CBC, C equals 2X plus 12. And I substitute in for X 8. So I get 2 times 8 plus 12. 2 times 8 equals 16 plus 12 equals 28. So we could see at 8 days, this point here on the graph represents 8 days and a cost of $28. So they're the same at that point. Now I also know that global only goes up by $1 a day and CBC goes up by $2 a day. So it's a safe assumption that after this point, global is going to be cheaper. But if I want to check, I can again use the equations to do so. So I'll just get rid of these. So I can check, I'll put in global first, C equals X plus 20. I'm checking what it is at 9 days. So 9 plus 20 equals 29. And now I can check with CBC. C equals 2x plus 12, which was our equation for CBC. I put in 9 again. And so I get 2 times 9 plus 12. 18 plus 12, because 2 times 9 is 18. And I get 30. And I can see at this point, CBC has become more expensive than getting advertisements from Global. So looking at the second part of the question, when would it be cheaper to use the second option? I can see again where the CBC line is lower than the global line on the graph. That represents all the times that it is cheaper to get advertisements on CBC. And as we discussed, as I just discussed, this point represents 8 and 28. And therefore I know that if I'm going to run my advertisement for less than 8 days, then CBC will be cheaper. So now we'll move on to page 13 in the tips booklet. For 2 of the classes, I was away on the day when this was assigned, so I just thought I'd go over it with you here. So just to read the question, each situation has a graphical model, an algebraic model, and a numerical model. Choose either the graphical model or the algebraic model to complete the table of values. Show your work and justify your choice of model. So for this is the first example, and there's 2 others in the book. Number 1 says, Big Pine Outfitters charges a base fee of $40 and $10 per hour of use. And then it gives you the different models that could represent this. And C represents total cost, T represents the number of hours the canoe is used. So in the algebraic model, the equation is C equals 40 plus 10T. And then over here, we can see the graphical model. And we're being asked to complete the numerical model here by filling in the missing values. So we can see in this one that C, the dollar amount, the cost, is the missing value in the table of values. And to figure this out, we have to choose to either use the graphical model or the algebraic model. If we use the algebraic model, then we use substitution. If we use the graphical model, then we just find the points on the graph. Okay, so for A is a fairly simple one. I would use in this case a graphical model because I can see the answer in the graph. I don't need to work out an equation to find the answer. So where T, hours, equals 0, which is here on the graph, I can see that the cost is $40. So down here in my solutions, I would write graphical model. And maybe I would draw a line on my graph to show that I understood that this is the point, and I could write in here y-intercept. Okay, so that one was easy enough to figure out. The answer is 40. Okay, so then B. In B, I'm given C, the value for C, as 70. And again, I can use the graphical model because I can see the answer in the graph. And so to do that, what I would do is I would find 70 on the graph, which is right here. And then I would see what is the value of x on the line where y is 70, and I would go straight across, and I would see that it's right here at 3. So my answer here would be 3. And again, I could write in here graphical model. Right, and I've drawn my lines on my graph to show my work. All right, then C says the cost is $230, and I need to find out how many hours that would be. Now, in my graphical model, I do not or cannot see the graph for values as high as 230 along the y-axis. So I can't use the graphical model here. I'm going to have to use the algebraic model. So I'm just going to write in here algebraic model. And now I can solve this using algebra. So when the cost is 230, how many hours? I'm going to have to substitute in 230 into C in the equation. So our equation, as you can see over there on the left, is C equals 40 plus T, or sorry, plus 10T. Okay, so I'm going to substitute in 230 for C. 230 equals 40T, 40 plus 10T. Alright, and now, as we've discussed, this is an example of a two-step equation. And what I'm going to want to do first is I'm going to want to get rid of the 40 from the right-hand side. So to do that, I'm going to have to subtract 40 from both sides. So I'm going to do 230 minus 40 equals 40 minus 40 plus 10 t. Okay, and once I've done that, then 230 minus 40 equals 190 equals 40 minus 40 equals 0 equals 10t, because this is now becomes 0. So now I have 190 equals 10t, and in order to do that, I'm going to have to divide both sides by 10, because 10 is being multiplied by t. So to get rid of that 10, I'll have to divide both sides by 10. And if I divide 190 by 10, I get 19. 10 by 10 is 1, and I can just write t down here because I don't need to write 1t. So 19 equals t, and I could write in my answer 19. And I've shown my work for this obviously on the right hand side, and I used the algebraic model. So that's how you do that series of 3 questions. Alright, so we're going to review question 3 from page 16 in the tips booklet. And before we begin, we're going to start with using cubes in order to analyze the question. So the question is, a carpenter is making a circular tabletop with circumference 4.5 meters. What is the radius of the tabletop in centimeters? So if I'm analyzing this question, I'm going to first circle the numbers. So I circle 4.5. I'm going to underline the question. What is the radius of the tabletop in centimeters? And I'm going to box any keywords, and there's a couple keywords here that you might miss, but you got to pay careful attention when you're analyzing a question. Radius is a keyword, and it's a keyword because it gives us the equation down here with diameter, so you need to remember that you're looking for radius and not just solving for d, the diameter. Then the other key thing here is to look at the fact that it's asking you for centimeters. And that's key because the circumference is given to you in meters. Okay, so one thing you could do from the beginning when solving this question is convert the meters into centimeters. And so if you convert 4.5 meters into centimeters, you will see 4.5 times 100, because there are 100 centimeters in a meter, and you will get 450 centimeters. Okay, so we're going to work with the 450 centimeters. So 450 centimeters to represent the circumference. I'm substituting in that number 450 for C equals pi d. Okay, so in this I can see that pi is being multiplied by d, and if I want to isolate d, I must divide both sides by pi. So I'm going to divide both sides by pi. And when I do this, I'm going to use the symbol of pi on my calculator rather than just 3.4, so my answer can be accurate. and I will get the number 143.24, and that's rounding to the nearest hundredth. So let me write that down. 143.24 equals D. And I've solved for D now, but I need to remember that the question is asking me for the radius. So I need to think of what's the relationship between the radius and the diameter. Radius is half of the diameter, so I would take 143.24 and divide it by 2. And when I do that, I get the answer 71.62 centimeters. So my answer, answer would be the radius is 71.62 centimeters. So now I'm reviewing question number 4 from page 17 in the tips booklet. So looking at 4A, the formula for the final amount A in an investment with principal P and interest I is A equals principal plus interest. Determine the principal if A is 6,000 and I is 750. So analyzing this question using cubes, I'm going to circle the numbers. I'm going to underline the question. Okay, and it's always a good idea to link the numbers to the variables that they represent, or the things they represent. So in this case, A is obviously 6,000 and I is 750. So now I need to write out the equation substituting these values in. So A was 6,000 in the equation. A equals, and P we do not know, plus I, which was 750. So this is just a simple one-step equation. And in order to do this, to isolate P, I'm going to have to subtract, in this case, 750 from both sides of the equation. So I would end up with 6,000 minus 750 equals P plus 750 minus 750. And then I would end up with 5,250, because 6,000 minus 750 gives us that number. And then 750 minus 750 equals 0, so I end up with just P, and that's my answer. 5,250 was our principal. So looking at 4B, the interest I is calculated by I equals P times R times T, where P is the amount of the principal from A, R is the interest rate, and T is the number of years the principal was invested. Determine the number of years the principal was invested if the interest earned is 750 when the interest rate is 6%. So I'm going to use cubes again to analyze this question, and it'll be very important for me in this case. So I can circle any numbers. I'm going to write them in standard form if they are not in standard form. So this is a percentage, not in standard form. I can change it to standard form by writing it like this. I'm going to underline the question, which is asking me to determine the number of years. I'm going to box the keywords. Really key here is it's asking me to find the number of years. Okay, and also really key here is in the introductory part, it told us the amount from the principal of question A. So that means that I'm going to be working with this number over here, 5,250, as the principal. I also mentioned before we should link the numbers to what they represent. So 0.06 represents the interest rate, and $750 represents the interest earned. So now I need to substitute the numbers that I have, which are 5,250, 750, and 6% into this equation. I equals PRT, or P times R times T. So I'm going to do that now. The interest, we were told, was $750 equals principal, which we know is 5,250. And then the interest rate was 0.06. And the number of years, which is represented by t, is what we're trying to find out. So to do this, the first thing I'll need to do is I'll need to multiply the two numbers that are on the right hand side of the equation so that they can just become a single number. And once I do that, then it'll just become a simple equation to solve at that point, and you'll see why. So I would do 5,250 times 0.06, and I would get 315t. And so now here I have 315 times t on the right hand side. So to isolate t, I'm going to have to divide both sides by 315. And when I do that, 750 divided by 315 gives me 2.38. So I can write down here 2.38 equals t. And then I can write out my answer. The principal was invested for 2.38 years. Moving on to question 5 from page 17. In this you are given shape formulas. In question A, you are given the shape formula for a circle, which is area equals pi times r squared, and you're given the value of the area, which is 63.585 centimeters squared. So to answer this question, you're going to have to use substitution and then solve for the unknown variable. So A equals 63.585 equals pi r squared. So to do this, we can see that pi is being multiplied by r squared. So what we can do to begin isolating r is we can divide both sides by pi. So we'll do that. And like in the previous example, I'm going to actually use the pi symbol on my calculator instead of 3.14, so my answer can be more accurate. And the answer I get is 20.24. And pi divided by pi is just going to be 1, so I'm left with r squared. Well, how can I isolate r squared? We can go back to what we learned in when we focused on the Pythagorean theorem, and that is I can just square root both sides of the equation. So if I can write it like this, square root 2024 equals r, and then I can punch that into my calculator, and I get the answer is 4.5. So r equals 4.5. Moving on to question B, we're given the equation for a triangle. Area equals half times base times height. And so in this case we're given, or area equals base times height divided by 2. In this case we're given both the values for the area, 27.3, and for the base, which is 6.5. So to do this, I'm going to use the first example of the equation for a triangle, which is area equals half times base times height. And so let's use substitution to do this. So the area was equal to 27.3. Equals half, or 0.5, I'm going to write it as, base, which was 66.5, and height, which is the unknown variable we're going to try to figure out. So to do this, first I'm going to multiply 0.5 times 6.5, so I can just make it into one number. And so once I've done that, I can write it out, and I get 3.5, so 3.25. So I write out 3.25 h. And so now I have 3.25 times h, so to isolate h on the right hand side, I'm just going to have to divide both sides by 3.25. Okay, and if I do that, 27.3 divided by 3.25 gives me 8.4. 3.25 divided by 3.25 equals 1, so I can just write over here on this side h, and I'm all done. And that finishes this review. Make sure you study hard for the quiz.